This is actually a fight between very many things. I'll be talking about nothing but fights in this talks this evening. I'm so mic'd up here, I feel like Lucretius of Borg, so you'll have to forgive me if I feel a little uncomfortable. So this is a small enough, the nice thing about a meetup rather than talking at a conference is that it's small enough that we can be fairly interactive. So I think some of you have seen this talk before, some of you know an awful lot about what I'll be talking about this evening. Feel free to shout out, wave your hands wildly if you want to contribute to say something to it. We're in a small enough group that's more than doable. That's perfectly reasonable. I don't have my glasses on, so as is so often in life, subtlety will buy you nothing. If you want to say something, shout or wave your hands. Yeah, you can shout out anything you like, as long as it's not "get off" or "he's behind you," unless you really need to, unless there's a really good reason to say he's behind you. So my name is Anne Currie and I'm the CTO of Microscaling Systems, and we've been doing an awful lot of work recently, well over the past year, looking into so Gabe talked about Deus being about Kubernetes, what next? We're kind of looking into, you've got Kubernetes, you've got Deus, you've got whatever orchestrator is in and in place. What next? What is the end game of all the effort that you've gone into potentially to look at those kind of things? What can it buy you? What's interesting about it that would justify all of the effort that's going in? Why are people so incredibly hyper? Why is there so much hyperbole around containers? So, and I think it's justified, but it's not wholly and completely justified. There's still an awful lot of work to get containers in. So, yes, so I don't think that anybody will be considering me to be exaggerating if I said that there are only two interesting things in the world at the moment. The first is containers, and the second, less controversially, is Game of Thrones. So, and you might feel that Game of Thrones bears no relation to your everyday lives in enterprise architecture, but you'd be quite wrong. There's a battle going on, a large number of battles going on at the moment that mean that your everyday lives are not quite so far from Game of Thrones as you might think. Maybe less sex position, don't know, depends where you work. But there is a battle at the moment for what will be running on the bare metal in data centers in a year's time, 2 years' time, 5 years' time. Where will your applications actually be running? What will they be running on top of? So what I'm going to talk about this evening is the main contenders in that battle. And I'm going to slightly kind of step back and teach my grandmother to suck eggs by summarizing the main contenders that you all know very well in this battle. And this is a little bit more basic than Gabe's talk, so I hope you'll forgive me. It will get a little bit more subtle as we move on. So, oh dear, didn't like that, did I? First contender, obviously, just running on bare metal. It might seem crazy, but it's what we were all doing 10 years ago, 15 years ago. Why don't we now? Mostly because it just wasn't sufficiently flexible, especially there are various, a bit like, a bit like Stannis there. It's not actually probably your winning contender here. It's inflexible. Spin-up times, if you want to expand your capacity, are very high. You're talking about, best case hours, probably more like days or weeks to expand your data center capacity if you're running on bare metal. So as its strengths, it's still fundamentally what we're all running on. It's been commoditized, but it's still fundamentally what we're all running on, but it isn't necessarily where we're running our apps directly, and it's unlikely to return. So it was beaten by VMs, and for good reason. So VMs, what's that? Yes. So it was written by VMs, and for good reason, because VMs have all of the strengths that physical machines don't have. They are massively flexible. They are totally agnostic. They don't care what they're running on, and they don't care what you're running on top of them. So the security is very good. They've been around a long time. Networking is excellent. And they have another advantage, which matches a little bit with what we were hearing about Deus earlier and some of the problems of some of VM's competitors. And this was something I didn't realize when I first started to look into this, but it's become more and more obvious to me that one of the reasons why VMs won so resoundingly and so comparatively quickly is because the technology, if you're an application developer, you don't know or care if you're running on a physical machine or a VM. It doesn't make the slightest difference to you. So as far as you're concerned, it's transparent. You don't know the difference. As an ops team, there was an awful lot of stuff to be learned in order to ramp up on VMs and to roll out VMs into production. There was a huge learning curve, but you also got all of the benefits of virtualization. So all of the work, all of the pain, but all of the benefits for virtualization resided within one single team, which was ops. With some of the alternatives that are now available, that pain is spread out more widely. And that's much more difficult to manage, it's much more difficult to deliver on. But VMs, I think one of their strengths is that all of the pain and the gain was within your operational team, which was an advantage. One of the downsides about VMs is that it is slightly overweight. You're running an entire guest operating system on top of an entire host operating system. That's a lot of duplication, and it means that you don't necessarily get the best server utilization that you could possibly achieve. The other downside of VMs is that the spin-up speeds, although they are so vastly better than the spin-up speeds for bare metal, for physical machines, are still way too long. You're still talking about minutes, which is not real time. And that's just, in my opinion, not good enough. So finally, you've got containers. The final contender for what your applications will be running on in a year's time, in 5 years' time. Has an awful lot of the strengths that VMs don't have, but an awful lot of weaknesses as well. So very, very lightweight. I mean, I think we all know that containers are extraordinarily lightweight compared to VMs. They are really just a way of packaging together processes and assigning permissions to them en masse, which means that you can bring up a container, which is basically just a bunch of processes in the same time as you would bring up a process, theoretically, in very much sub-second, which is amazing. Now, by the time you add in orchestrators and you're not necessarily achieving sub-second, but you're still achieving very, very, very quick instantiation. So that could potentially completely change things. So their weaknesses are, as Gabe mentioned, networking still isn't perfect for this. It isn't really living up to the possibilities of containers. But there are some really good options out there. In fact, I mean, one of the leading ones, as well as Weaveworks, there's also Project Calico, who are based in London, and that's a very, very compelling way of doing container networking. The security will get there. Everybody's working on the security. I think it will get there. But it's still unseasoned. One of the problems with running containers in production is it is relatively new. There are still a lot of flaws, issues that need to be ironed out of that. But we'll get there. We'll get there. So, but all of that, I mean, that's all great, and also about Docker, and it's great for continuous integration, and people love it, and they can move things very easily from dev to test to production, all that kind of stuff. I don't care about that. That's table stakes. If that wasn't good, we wouldn't even be talking about containers now. What I'm really interested in is what's next. What does that buy you that's bigger than just continuous integration and easy movement from one machine to another? And for me, that's all about the speed of container instantiation. It's the speed at which you can bring things up and down in containers compared to VMs. And I think that completely changes how we might think about architecture and operational architecture and development architecture in the future. So, for example, the main thing that always gets on my nerves with VMs is autoscaling. It feels like it should be incredibly useful, and it is useful in a way, but it's always disappointing because it's not real time. So I spent a couple of years as head of technology for an e-commerce company, and certainly autoscaling would have been good. We weren't in the cloud. This was pre-cloud. This was running our own data center. And it would have been useful to have autoscaling, but it wouldn't have solved all our problems for us, because our problems were always about unexpected user demand. And when user arrives at your website, they're not going to wait around for the 4 minutes required to fire up another VM to expand your capacity to handle it. That's not good enough. It's all right, but it's not good enough. You're still going to lose all of those people. So autoscaling is just not quite good enough. When we first started to hear about containers, it was autoscaling that we were starting to think, well, hang on a minute, is there something more that can be achieved here with container instantiation speeds? And when we started to look into it, and we looked into what Google are achieving or Netflix are achieving, they are achieving real-time scaling, but they're not doing it using autoscaling. Because autoscaling, expanding your capacity, you still can't do that in real time. Whether you're bringing up additional VMs or you're putting in new machines, you cannot do that in real time. But they do something else, which relies on some of the abilities, the capacities of containers and the container instantiation speeds that allow them to do real-time scaling within their existing capacity. Now, they still call this autoscaling, but I find that a bit confusing. So we're calling that microscaling to differentiate it from autoscaling, which we consider to be expanding your existing capacity, and microscaling to be reusing your capacity. So, for example, say it was me again, and I had my e-commerce platform, and I had web servers, and I had something else. Maybe it was processing warehouse management orders. Now, some of those processes, some of those services that I'm running, the web service, is utterly key. It is entirely what my business is. It's if there's a peak in demand, it's web services I need to take orders. Doesn't really matter. It's important to me. It's enormously important to me if that orders are still processed in the warehouse. But if that didn't happen for 20 minutes or an hour or a day or a week, that wouldn't be the end of the world. But I absolutely need my systems to process web orders as they arrive. That's what my business is all about. So the way that Google have approached this and the way that Netflix have approached this is that they've used orchestrators, and you really need a good orchestrator to do this. So you need Kubernetes or you need Mesos, and we're not attempting to write those. We're just saying, what can you do once you've got them? You've got Kubernetes, you've got Mesos, you've got Nomad, you've got ECS or whatever orchestrator that you might want to put into your systems. What you need to do is tell that orchestrator, well, just for a moment, switch off all of those warehouse management systems. What I would do, switch off all those warehouse management systems because they're important to me, but they're not urgent right now. And use that capacity that I already have. I'm not actually autoscaling. I'm not expanding my capacity. Reuse the capacity that I already have in order to do more to support the demand that is urgent for me, the processing of web orders. And this is what Google and Netflix do. And it works extremely well for them. The end game for me, this is the reason why containers were invented. This is actually what they didn't invent it in order to use Docker, because Docker wasn't invented until years after these guys started to do this kind of thing. It was invented in order for you to do very clever things with your infrastructure, like that. And even further things beyond that, but that's for another talk. But at the basic level, this is the most simple thing you can do with your infrastructure. Using containers is turn off one thing in order to free up capacity to turn on other things. So what's required for that? Well, container instantiation speeds are required for that. If they don't actually instantiate within seconds, then you've bought yourself nothing. Microservices. If you just have a giant monolith, then you can't get any benefits out of this approach, this containerized, orchestrated approach, because you've got nothing to turn off in order to free up capacity. You've just got one giant monolith, just got nothing to turn off. The only option you have is to spin up additional resources. Also, cattle not pets. if it takes 10 minutes to turn your warehouse management system off, then you've bought nothing again. You may as well have just put in some additional VM resource. So in order for this to work, you need to have a microservices approach, which isn't crazy talk. Most of us are thinking about microservices approaches, and you need a cattle not pets approach, which again isn't beyond the realms of possibility. But I'm saying this, and is it actually true? I mean, I want to believe that all of these things are possible. I know that microservices are possible. I know that cattle not pets is possible. But we didn't really know when we started looking into this whether these container instantiation speeds were actually achievable with off-the-shelf orchestrators on the kind of infrastructure that we might have, so physical machines or EC2, Azure, or wherever you wanted to put it. So that was the first thing that we wanted to find out when we started to look into this. Is it actually true, or is it just a giant conspiracy on Google's part? So here we go. So this is actually recorded off my laptop last week. Let me turn the volume down. Where's the volume? Where's the volume? Oh, well, it'll do. So this is something that I'm going to do a sort of epileptic fit if I look at this too long. Don't look at this. So this is something that we put together, Microscaling on a box, which is a demo, a bit of experimentation to see whether or not these container instantiation speeds are actually plausibly achievable using off-the-shelf orchestrators and off-the-shelf infrastructure as a service. So here, what we're doing is, so what we did to mock this up was we generated some pseudo-random demand. So the red is pseudo-random demand. And we defined two container types. So dark blue containers is our priority one container. And that's a bit like our web server. It's basically it's the service that is required in order to meet the demand. And then we said, okay, microscaling in a box, here's your algorithm. You win if you keep up with the random demand, so the blue hits the random demand line, and the rest of the capacity in the system is topped up with your kind of batch, your priority 2 command, which might be a warehouse management system, it might be a batch process, whatever else we wanted to want. We genuinely didn't know whether or not this would actually be possible. This was what we thought of as the simplest possible demonstration that we could do to see whether this was possible. As you say, it generally does win. So it wins, there's a win. If it meets the demand and it fills up the boxes, that's a win. That's a win. And there we've got it changing every second or so. And that was about as good as we managed to achieve. So we ran this with Mesos as an orchestrator, Mesos Marathon as an orchestrator, ECS as an orchestrator, Swarm, and also directly using the Docker APIs. And all of them behaved actually really very similarly. We only used Docker, well, I'll talk a little bit about that later. We ran it on EC2, we ran it on ECS, and we ran it on Azure. And again, they all behaved perfectly reasonably. So it's not crazy talk. This is actually possible. The only place where we didn't really get great results was where we were running Windows 2016 beta Docker container engine support on Azure. But that isn't a production. And there the Docker engine was just responding a little bit too slowly to keep up with this. But that's not a production configuration. So I'm prepared to forgive them for that, because I think this is not the kind of thing that they were necessarily immediately expecting people to be doing. But generally it works. Generally you can achieve these kind of speeds. And it was not a given that that would be the case. So we were quite pleased that it was. And I'm not going to hold it against Microsoft too much that they didn't quite manage to keep up. So,
did you try to do spikes?
Yeah, but it looks terrible. We have done spikes, and it does actually, it will keep up with that. It's just that it doesn't look quite as good when you're demoing it, because it looks a bit crazy, and it's quite hard to follow as well. It doesn't make that much difference. Oddly enough, you can start and stop 10 containers in pretty much the same amount of time as you can start and stop one container. It's really the orchestrator that's introducing the slowness into that. And we did have to tune the orchestrators a little bit to achieve that, but not hugely much. So we had to do a little bit of mucking around, but it wasn't major. We haven't done it with Kubernetes yet, but I don't anticipate there would be any problem with that. So really, this is, if we hark back to Gabe's talk before, and he talked about application ops. This is really, I would say, all lying in that application ops layer, and it's really saying, can your infrastructure know a little bit more about what the applications are doing, and manage that a little bit better? Because if you can start to bring in real time, particularly with microservices, there's a lot you could potentially do with that. There's a lot of interesting things coming out of that. Whether it's especially, and I hadn't really thought about this that much before, but the comment about what was it called? It was composite microservices. There's potentially a lot you could do there, where you're kind of, in many ways, the system that I'm talking about is a composite microservice. It is a e-commerce company, and it is made up of many microservices, some of which are doing your web front end, some of which are doing your payment processing, some of which, and they are. The argument that I'm making is that they are mutually dependent. Right now, they're not. They're all just completely set up separately. But really, they are mutually dependent upon one another, and they do depend on what your business is doing. And they should depend upon what your business is doing. And the comment about almost fly-by-wire on your systems, that's what these guys do. They make real-time judgments about what should be running, what's important to you, what matters, how it should be behaving, whether there should be more of these or less of these. And they act on them instantly in real time using their orchestration layers. Yeah, and this is the throne that everybody's aiming for. I think that we should, in the long run, now this might not happen for 10 years, but I would be very disappointed if it doesn't happen, given that these other guys are already achieving it, and they're getting some hugely good results out of it. Lower costs through higher server density, lower maintenance through effectively self-driving, self-flying systems, and more than humanly possible. I mean, someone was saying to me the other day, oh, I'd just have somebody in a room pressing the buttons. No, that in the long run, that is not the way that the world will work. We do want systems to manage themselves. With containers, I think that is coming closer to reality, that actually a lot of the application ops stuff that was mentioned before might in the long run hopefully be automatable. So I talked about a battle between VMs and containers, but actually it isn't really true. That battle has already been fought at places like Google, and containers won. We're just only now hearing about the results of that battle. I think in the long run, we are definitely going to go there. Now, I could be wrong, because a lot of these same effects could be achieved by just making VMs considerably more lightweight and better orchestrated. So we might get to the same end result, but not with containers. We might do it with extremely lightweight VMs, like Hyper-V for Microsoft, or unikernels on Zen, or whatever. There are lots of different options that might give us the same kind of incredibly good response times that are not necessarily containers. But the general idea, I think, still applies. Yeah, I mean, it's not crazy on your ops. You're really talking about having an orchestrator. You really do need an orchestrator to make this work. And a Docker or alternative, and you need to be thinking about microscaling or that kind of approach of effectively automating your application ops. And architectural requirements are microservices and cattle, not pets. I did really enjoy the last, I don't know, so I'm now going to move into the, there we go, I got my last Game of Thrones reference. Containers are coming, or container equivalents, I think something that is as fast. I would go into, I do want people to participate and ask questions, but I'm going to make one final comment from the last talk, which was that actually I think the thing that's most threatening to this world, and I think it's a world that's really worth achieving, is the energy barrier. So Docker is quite a low energy barrier. To get from developers to nothing to playing with Docker is a very low energy barrier, and that's where they've been successful, is keeping that energy barrier extremely low. But moving to the next stage of having orchestration in production, that's a huge energy barrier. And there are a hell of a lot of companies and developers sat between that initial hump and this huge hump over here of orchestrators. And I think that's a real shame, because I think once you've got orchestrators in production, there's such a lot you can potentially do with it. So I'm quite keen to play around with Deus, because anything that helps get people over that second energy barrier will, I think, in the long run be a very good thing. So, has anybody got any comments or questions? Doesn't have to be a question, can be a comment.
Containers are dead. The next thing is AWS Lambda and those sort of services.
Well, it's interesting, because I think that the AWS Lambda and serverless architecture is almost stepping on from this, but they'll be very difficult to orchestrate. I mean, it will be quite hard. I mean,
the tools aren't there yet, but the tools weren't there for Docker. So.
Yeah, that's true. And to be honest, I wouldn't really mind if that happened, because you can do all of these kind of things with that. Or yes, so when I said lightweight VMs or containers, there's also serverless code. Yeah. Is another way that you could achieve it. It's going to be, I would quite love that world, actually, because there's a lot of interesting tooling that would come out of that would kind of match the same kind of thing that we're thinking about doing at the moment anyway. It's that then, once you get that, how do you make them more aware of one another and able to kind of because the difficult thing is you've got a 1 million line application. It's difficult enough to microservice that. It's difficult enough to turn that into 4 250,000 line microservices. But people can do it. It is possible to do that. But you're probably not going to really ever want to turn that into 1 million single line Lambda, serverless Lambda. That'd be really hard to manage. But I like the idea of it. With just the right different kinds of applications. And I think in that world, the infrastructure just has to be really clever to make the actual application so dumb.
But I mean, that's what the tools, orchestration tools now, are actually doing that. They're working on container level, but to take that down to process level, effectively what Lambda is, it's just a different concept. So
I
mean, it's the next step. So containers are dead.
I think you're probably. I think there will certainly be a continuum in which serverless code does appear. It's quite interesting. It's definitely interesting. Well, I'll go from the front and then work back.
I've gone down the container route. It's not dead for me. So where my interest is in terms of that, it does allow us to have a very easy deployment from development straight on into production as a way of pushing. But also is that what interests me around in terms of this area is that I will use different hosting platforms. So I'm going to be agnostic. If the customer says I want to be on AWS, fine, I'll spin up on that. But I do have a multi-tenanted web front end and a back end, which is basically a Spark cluster. So essentially is that each customer has their own storage and their own compute, but a shared front end.
Yeah.
What's interesting with some of this microscaling, because for say some analytic jobs, I want to have the customer be able to say, hey, I want to run this in half the time, so spin up twice as many servers.
Yeah.
And I use a Lambda type architecture where I just spin it up, do the work, spin it back down again. So it takes care from a cost perspective in hosting. But there doesn't seem to be a connection as much between the billing that I will get from Microsoft or Google every month, and me kind of aligning that to what I have to charge my customer, in terms of that seems to be disconnected. So we're getting the ease of deployment, the ease of scaling, but maybe not where you're a platform as a service, so that you have another customer that you're then brokering that hosting relationship essentially to, because all they're seeing is a web front end. They don't understand anything that's going behind that. It's like an iceberg, you know. And in that case, I think some of the hosting companies seem to be away from that. So I'm just wondering whether that's an area that you've seen any work in, or.
No, actually, I wonder if you've got any more comment. You would have any comments on that from you're closer to the PaaS world. I kind of hope that now that, because obviously AWS have basically just completely cornered the market. You know, they have what, 92% of the cloud market, and Azure have what, 6%, and everybody else is just picking up the, you know, the crumbs. I think the next one is Google with about 1.5%, which is not a very healthy world.
But I think also is that where this world is because I'm certainly seeing different fundamental shifts happening, and I think that where Amazon clearly is in way out of front. Like I have people, friends who work there, and like they're provisioning infrastructure that used to run Amazon every 90 days 5 years ago. So the infrastructure they had 5 years ago running Amazon, they provisioned every 90 days. Like I don't know where they're kind of sparking up these data centers, but I do think that there's still, what's happening is that we're still kind of climbing up the maturity curve. You know, so we're having the platforms, you can have Hadoop, you know, you can have Spark now, so you can get much more interactivity. You're having people like Databricks come along and make it really easy to run analytic jobs. But eventually you're going to get to solutions that run on these platforms. You know, so that maturity curve just always happens. You know, and that's why I don't think the battle is over. I certainly do think that Microsoft has been very pragmatic in terms of their support for Linux. You know, in terms of them porting SQL Server to Linux. Like, you know, this must be the over the dead body of Baumer.
Well, he's dead.
He's selling his shares or something, you know, given what he said about, I think Linux was communism or something. And I can't think about what he said about the other one. But, you know, so they're being very pragmatic.
I think they could be more pragmatic. I think they're being pragmatic, but because I used to work on, I worked on Exchange back in the 90s. I did a lot of work for Microsoft back in the 90s. I think they could be more pragmatic. I think they should be thinking about open sourcing Windows. I think if Bill was still in charge, he would do that, because I remember I was on the very old-fashioned SNA server. I'm not sure if anybody remembers SNA. It was one of the Microsoft back office suite, and I worked on Exchange as well. And back in the 90s, the Microsoft back office suite existed only to keep Microsoft in the game of servers, of Windows servers. They existed only, it was what was required at the time, and you know, they didn't make any money off it. It was required at the time to keep Windows Server in existence as a server operating system. And at the time, I mean, Linux didn't exist. They were competing against Solaris, AIX, HPUX, all of which are now gone. You know, and it feels to me that now, if they want to keep themselves in the game as a server operating system, they have to open source. And I don't think it would actually do them any harm to do so. I mean, it's completely against what they've been thinking for the past 20 years, but I don't think they'd be crazy to be thinking that. I don't know if they will, but I don't think they'd be crazy.
I think like, even like if you look at the Office 365, where you now rent, like I pay $5 a month for Office. You know, you don't buy it for a couple of $100 anymore. That's changing their business models. Yeah. You know, so business models for traditional companies have to evolve.
Yeah, I agree. Oh, sorry, there were more questions. You had a question, Colin.
Yeah, I was just wondering, a lot of what you were saying was very focused on latency, as in how fast can we spin up a container. And to actually doing some useful work, quite often is the combination of these container spin-up speed, but also perhaps like the app server spin-up speed. So we've seen this move away from like fast CGI style development towards things like JVM-based development and like .NET. But do you think we're going to go back to fast CGI style development, very fast startup speeds, and in the future we're all going to be writing Perl and PHP? And if that is the future, can I step out of it?
Well, I think there will be, to take full advantage of these things, yeah, there's definitely an issue there. And I've got people that I'm talking to at the moment who are saying, I really want to do that. I really want to be able to respond, but we're running, you know, a Rails server and it takes a couple of minutes for the whole thing to come up. And what will they do about that? What will we do about that? We'll probably end up architecting things to, I mean, the whole thing about microservices is you can break down some of the stuff and, you know, people move some parts of it out into a microservice that might be written in a different language. Yeah, so you don't like the idea of the Lambda future?
I do, I just don't like PHP.
Ah, you. I'm sure we can do it without PHP. Yes.
How does that happen, and who makes those decisions, and how's it configured?
Ah, that's a very good question. So the question is, I don't know, because we haven't written anything to do that yet. But I mean, I would imagine it would start with configuration files, you know, that actually, and it's in many ways, it's passing that decision. The interesting thing is that is a business SLA decision. You know, I care about this. In these circumstances, I care about this. I don't care about this. And so that decision has to be passed back to business users. And, you know, I think business users, it was something that I saw when I was in weekly trading meetings for our, so it was figleaves.com, so online lingerie. Every week we'd sit down and go, are we selling enough 32 Bs? You know, we'd have all those conversations. And often the business do have a very good idea about that kind of, well, this is important to me and this isn't. They do understand that. So, for example, one of the difficult things was always getting the marketing team to communicate the information that the ops team needed to provision successfully. But the irony is it was the same information. You know, the marketing team cared about the ROI on a campaign, which was really how much traffic is that going to generate, how many orders is that going to generate. The ops team cared about how much traffic there was going to be and how many orders they were going to place. So it's often, bizarrely enough, exactly the same information that's required across a whole business. And we're all going to have to find a way of making business users share that information with one another. And it's entirely a psychological question, I think, because the actual information is the same, isn't a million miles apart. So they do know that kind of thing. And businesses can make a decision. Somebody non-technical can make the decision. If we had a huge number of users, I prefer that the website stays up more than I prefer that payments are collected. Yeah, and yeah, I think in the future they're just going to have to make that decision. Good, that's it. We can all go off and eat our own weight in cream eggs. Hooray. Cool.